Okay, today we're going to talk about interpreting remainders. So when you're interpreting remainders, basically what that means is based on the story that your problem is part of, what are you going to do with the remainder? And I'm going to show you 3 different examples of stories that are going to do 3 different things with. So you're basically going to do one of 3 things. 1, you could round up the number. 2, you could represent it as a fraction or a decimal. Or the third option is that you would ignore it. So here's our first scenario, the party problem. So I have 68 guests coming for a dinner party. I need to rent tables. The tables seat 8 people each. How many tables do I need to rent to seat all of my guests? Okay, so first of all, let's find our information. So we have 68 guests coming, and we're renting tables, so 8 people fit at a table. So the question is, and we're going to use a division problem, right? 68, this is our number model, divided by 8. Okay, so now let's do our division. So 8 as our divisor, 68. So 8 goes into 6 0 times. 8 times 0 is 0. Subtract and I get 6. Bring down my 8. How many times does 8 go into 68? It goes in 8 times. 8 times 8 is 64. Subtract and we get 4. So we have 8 remainder 4. So the question is, do we round up? Do we represent it as a fraction or a decimal, or do we just ignore it? So let's start with ignoring it. If we ignore this remainder, meaning that we're only going to order 8 tables to rent, that means that 4 people, this remainder over here, are going to have to stand at my dinner party. Chances are they're not going to want to come back to my next dinner party if I made them stand during the dinner party, right? So that is going to be a problem. So we're not going to ignore it. So that's our first thing we can eliminate. In representing it as a fraction or a decimal, if I were to represent this as a fraction, it would be 8 4/8, which can be reduced to 8 1/2. If I call the rental company and ask for 8 1/2 tables, chances are they don't have half a table. So we're not going to be able to represent this as a fraction or a decimal. So we're left rounding it up. So when we're rounding this up, that means that instead of 8 tables, we actually need 9 tables. Okay, so that's what I mean by rounding it up. And these 9 tables will now be able to seat all of my 68 guests. All right, so that's the party problem. We have the party problem where we rounded up our answer. So we had enough tables for our guests to sit in. Whoops, I skipped one. Is the cookie problem. So if I have 25 cookies to share equally with 3 of my friends and me, because I don't want to be left out of the cookies, how many cookies will each person get? So I'm going to circle the information I need. I have 25 cookies and I have 3 friends and me. So that's going to be important too. How many cookies will each person get? So my number model here is 25 divided by not 3, but 4. I am the 4th person, right? So 25 divided by 4, which is gonna be, so we have 4 and 25. Okay, so can 4 go into 2? Nope. 0 times 4 is 0. Subtract and I get 2. Bring down my 5. 4 goes into 25 6 times. 6 times 4 is 24. Subtract and I get 1. So 6 remainder 1. So here's the thing. So let's start over here with rounding it up. If I round this up, I can't just magically create extra cookies out of the world here. So I can't round this up. I can't round it up for everyone to get 7 because I don't have enough cookies to have everyone get 7. 6 is all the whole cookies that I can get out of this. I could represent it as a fraction and decimal, and would I ignore it? If I ignore it, the first thing everyone's going to say is, what about that extra cookie? We could totally split that in half, right? So we're not going to ignore it. We are going to represent it as a fraction or a decimal, and here's why. If I have 1 cookie, right, let's say this is the cookie, I could split it up into fourths, which means each person would get 1 of the fourths. So this would be 6, whoops, my pencil went away, 6 1/4 cookie, or if we represent it as a decimal, 6 25 hundredths, or 6.25. Okay, so that's the cookie problem. So if you have something you could actually cut into pieces, then you can represent it as a decimal or a fraction. We had the cookie problem where we were able to cut it up, and so we could represent our remainder as a fraction. Okay, so the M&M problem, lots of fun with the M&M problem. So it says, I have 57 M&Ms and I want to put them evenly into 7 gift bags. How many M&Ms will be in each bag? So if I circle my important information, 57 M&Ms, and I have 7 gift bags to put them into. So 57 divided by 7. So our problem will look like this. So I have 7 as my divisor, 57 is my dividend. 7 goes into 5 0 times. 0 times 7 is 0. Subtract and get 5. Bring down my 7. 7 goes into 57 8 times. 8 times 7 is 56 with 1 remainder. Now, I don't know if you've ever tried to cut an M&M in half, but you're going to end up with M&M dust. Like, you're not going to get part of an M&M. It's just going to shatter. So representing this as a fraction is not going to be possible. So the other possibility here is to round it up. Again, I only have 57 M&Ms. I can't magically produce more M&Ms. So we're going to have to also cross out the rounding up. So we're left with ignoring it. So there's no way to cut it up. You can't make more M&Ms out of nowhere. So we're going to have to just ignore it. So technically, each gift bag is going to get 8 M&Ms. However, that one that's ignoring it, I'll probably just eat it myself. So anyway, we're going to have this remainder is actually going to be ignored. So 8 M&Ms per bag is how we would represent that in the answer. All right, guys, that is representing remainders. And then we had our M&M problem where we had to ignore it because you can't cut M&Ms into pieces or else you get M&M dust. So that is remainders and how to interpret them in word problems. Thanks, guys. Bye.